Hey everyone, this week we'll be going over a base running advanced metric, and that is weighted stolen base. Now, I have it here on Fangraphs, and weighted stolen base runs estimate the number of runs player contributes to teams by stealing bases as compared to the average player. It's the base stealing counterpart to weighted runs above average. So I recently came out with an article that published linear weights at the Division 1, Division 2, and Division 3 level from 2013 to the present. And part of those linear weights are the run values for stolen bases, which is set at 0.2 every year. So you can see down here in this paragraph, in this case, run value, the stolen base set at 0.2 runs for all seasons. And then the run caught stealing as well, the run value of that, it's just 2 times runs per out plus 0.075, and I calculated that as well. And I also calculated for you the league weighted stolen base runs, so essentially it's just the league stolen bases times the run stolen bases plus the caught stealing times the runs caught stealing, divided by singles plus walks plus hit by pitches minus intentional walks. So I have all that data for you for the 2013 to 2019 season, and what essentially weighted stolen base does allows us to see how much value did a person create in stealing bases, because in the grand scheme of things, if someone steals, say, 10 bases but gets caught 4 times, they're actually more than likely, at least at the college level, costing their team runs rather than adding their team runs. So it's kind of understanding that weighted stolen bases is important in kind of measuring the exact value when converting it to runs. So baseball is a game of runs. Obviously, to win, you have to score more runs than your opponent. So the best way to do it is to see, okay, what's valuable, what's not valuable. So we're actually going to look at a paragraph in here, is because this sentence right here: if you steal 10 bases and get caught 10 times during a season, your stolen base actively has cost your team runs, because the value of advancing 1 base is smaller in magnitude than the cost of making an out. And you'll see that in the code when I show you, but essentially at the college level, you'll have to steal every 3 bases for each time you get caught stealing for you to even have a positive run value. So definitely be on the side of, if you're going to steal bases, you better have a high likelihood of stealing bases. So we will get into it. The first thing that we'll do is load in our library tidyverse to get the necessary packages that we need to load in order to make the function for weighted stolen base. So just call it tidyverse. It might give you some signs after this, but don't worry about it. That's just saying it's working. And then we'll call 2 CSV files that I will share with you on my GitHub page. First one we'll call dat read CSV player underscore data.csv, and then strings as factors equals false. So load that in. As well, we'll load in the guts page, which is essentially those constants that I mentioned earlier: the run stolen base, run caught stealing, things of that nature. And we'll say d1 guts weighted stolen base .csv strings as factors equals false. Again, if you have R 4.0, you don't need to type string as factors equals false because they're automatically false, but just letting you know. So let's look into the dat CSV file. So I'll just type in here view dat, and it gives us data for all players who attempted at least 1 stolen base. So the approximately has 25,000 players, and it goes all the way from 2013 to 2019. So hey, great way to get the weighted stolen base numbers. So what we'll do next is we'll combine the data frame. So how you do that is you'll simply say dat equals left join from the dplyr package, which is under the tidyverse package. Dat is your x, guts is your y, and by equals, in parentheses, year. And then we can skim through the data frame just to see that it has the correct totals. It does. And yeah, feel free to skim through the rest of it. Now we can calculate weighted stolen bases, and simply how you do that is we'll say dat equals dat piping operator mutate, and then we'll get into our calculation. So wSB, which is weighted stolen base, double parenthesis, stolen bases times run value of stolen bases plus caught stealing times the negative run value of caught stealing, so just run CS in this case, and then you still have two parentheses. Then we'll say minus, and then another parentheses, the league weighted stolen base times the singles, which is X1B, walks, plus hit by pitches minus intentional walks. So we should have all of that, and then we will arrange, which is another dplyr function, negative weighted stolen bases, which essentially just means we're going to arrange by descending weighted stolen bases. So you can run this, and then what I like to do is just make sure it's rounded off. So I'll just do dat $, which is to indicate a column, weighted stolen base, round dat wSB 2. And we can go look into our data frame. We can see that some guys have almost 8 runs in weighted stolen base. So from 7 to 5, let's see on the negative side. So someone like on the negative side, negative 4.36, so that player costs his team about 4 runs in stolen bases. But usually the good players are somewhere in between 3 to 5, at least at the major league level. Best, I think they said on that article there were 22 players that had more than 10 weighted stolen bases, but obviously if you steal 40 bases and don't get caught once, you're going to have a pretty high weighted stolen base. So Ryan Lazo did exactly that in 2016, and Zach Coppola in 2015 did that as well, but had 1 less stolen base. But then some guys like JD Orr, I had the pleasure of seeing him a few times. He very fast guy. I think he ran like I want to say like a 3.9 to first base, so pretty quick. But he had 70 stolen base attempts, 60 stolen bases, 10 caught stealing, which resulted in a weighted stolen base of 6.45. So now what we'll do is, from the weighted runs above average video, we'll do essentially the same thing. So in terms of creating a plot, so we'll say DevTools install _ GitHub lbenz 730 NCA hoopr, which again, if you like college basketball data, this is the package that you can use to get that, and then we'll call it in our library by calling library NCAA hoopr. Feel free to use this line of code right here if you want. If you already have it, you don't necessarily need to use it. So we're just getting colors. So what we'll do next is we'll say colors equals, and then we'll just assign that data frame NCAA colors after we call it NCAA hoopr. So colors equals NCAA colors. And then we will change one of the names. So we'll say colors piping operator dplyr : rename. The reason why I use dplyr : in this case is when I was doing this before, I was having trouble correctly renaming it. So I just said dplyr : rename school equals NCAA _ name. And it should come up as such. And then again, we'll do another left join. Dat equals left join dat colors by, and this time, school. All right. Now, next, we'll do a top 10. Like I mentioned, again, in the weighted runs above average video, it should look pretty similar. So, top 10 equals dat piping operator mutate player year equals paste 0, and what that essentially does is takes the player name and the year and puts it into one singular string. So paste 0 player, comma, dash, so that way we understand that there's a dash in between the two, year, and then again we'll arrange this just to make sure. Arrange weighted stolen base, and we'll say select year, player year, school. This time I said secondary color because if you use the primary color, some team logos would not appear. And then logo URL, as well as the weighted stolen base. And then we will arrange, or we will select the top 10. So top underscore n from the dplyr package 10. Run that. And so it'll tell you selecting my weighted stolen base. And we can continue on with our code. And this is into the ggplot. But first, make sure you load in the library GG image. So library GG image. So that way this is used for getting that logo plotted onto our plot. So plot, ggplot, data equals top 10. AES for aesthetic, and then X equals reorder. Again, the reason why we use reorder in this case is so that way the bar chart will be ordered from greatest to smallest, in this case the top 10. So player year, and then negative weighted stolen base, which essentially again means descending, and then we'll say Y equals weighted stolen base. Add a plus sign to continue our code. We'll say geom call fill equals top 10 secondary color, so we'll select that, and then we'll say plus theme equals legend position, and we'll say none. So that just means we're going to remove a legend for this particular plot, and we'll continue on, and through the GG packet or the GG image package, we'll say geom image equals top 10 logo URL, the aspect ratio, which I just go with 16:9 in most cases, and then we'll nudge this, so nudge Y equals -1. So that way we can adjust it and you can fully see the logo in each of the plots. So then we'll add a X label, so xlab equals player in year, add another plus, ylab, which is the label for the plot, weighted stolen bases, add another plus, geom text, so we want the number of weighted stolen bases displayed as well, so again another aesthetic, this time we'll say label equals weighted stolen base, and then we'll do a vertical adjustment, so vjust equals -0.2. How I came up to -0.2, just guess and check what I usually did. So when I ran this plot, just find a number that fits. So -0.2 fits, and then font face equals bold, because we want the data in bold, and then we'll add a title lastly. So GG title, top 10 weighted stolen bases from 2013 to 2019 in D1 baseball. And so we'll go up to the top, we'll run all this, give it a second to load, and it should appear with the team's secondary colors and their logos. So I will zoom in so we can analyze a little bit further. Now we can see the graph zoomed in, player and year, and their team logo. So in 2016, Ryan Lazo has the highest weighted stolen base with a 7.99 weighted stolen base run. So he essentially added 8 runs based on just his stolen bases at Texas Southern. Zach Coppola at South Dakota State had 7.79. Ben McQuown at Campbell, 7.28. And then we have 3 guys over the next 4 guys who did it in 2019. Simon Whiteman with Yale, 6.68. J.D. Orr, like I mentioned earlier, 6.45 at Wright State. Mike Alexander, 6.14 with Delaware State. Jay Charleston with Tennessee, 5.93. And then Jeff Roy in 2013, Rhode Island. Nick Richter with Rider, 5.77. And then Gavin Golson with a 5.6 in 2015 with Jacksonville State. Thanks for watching. Really hope you enjoyed. If you did, like and subscribe so I can continue making future great content and you can be able to be the first to see it. And always have a great day. Thanks for watching.